then sine cube theta is equal to, before I do cube, sine theta is equal to the square root of x squared minus 1 over x squared, which is equal to x squared minus 1 over x. Is that right? And then that means that, where am I going to put I? That means then that I is equal to minus 1/3 times 1 over sine theta times 1 over sine squared theta plus c. Do you see what's about to happen? So I is equal to 1/3 times x over the square root of x squared minus 1. Why did I invert it? It was in the denominator, right? Right? Times x squared over x squared minus 1. Which is equal to x to the 3rd over x squared minus 1 times 3 times the square root of x squared. How about if I just say, can I say 3/2? Is there anything wrong with that? That looks better to me than what I was about to write. And I gotta look at it and see. Say what now?
-1.
Yeah. How about that? Leave it alone. Stop there. By calculus 2, a fractional exponent looks better than radicals. Let me get it where you can see it all on one page, and you can ask me questions. Questions?
That's what be plus C. Plus 1.
Miles, which mathematician discovered this?
Jeez.
I don't know, he must have been bored though.
Now, did this come about after calculus was invented, like 100 years into the thing? 'Cause
No, I don't.
It's rather ingenious, you know what I mean? You wouldn't think of using that method.
Yeah. Yeah. Yeah, I take back my no. I think it might even be more than that. I think you might first have to have pompous asses and PhDs. Someone got their PhD by doing developing trig substitution.
Remember the comment about the dog walking with its hind legs?
Yeah.
It's not that it's done well, but it's done it all.
Yeah.
say there are two of these? on
Would y'all say,
the
would y'all say that probably the key was changing things to sine and cosine? I'm telling you, when we got to here, you do know that's minus 1/3, that's minus 1/3 cosecant cubed, right? But from here to minus 1/3 cosecant cubed is a long way to go, isn't it? Yes, sir.
So pretty much anytime we get like,
Louder?
so pretty much anytime we get like a secant and a tangent where we can't get the u and du just
Yes.
right, go ahead and change the sine and cosine.
Yes. Now, I'll bet every one of us in this room, if that had been a square, we would have just done tangent and secant, wouldn't we? Do we agree? But it wasn't, and we knew we were going to have a secant left over, and at the time, I couldn't think of a good thing to do with it. Travis?
Why did you need to break it up into the sine, 1/sine theta times 1/sine squared theta?
Because at one time, Travis, I was thinking about writing my answer like that and leaving it pretty. I was planning on leaving my answer as 3 times x squared minus 1 in front of the radical x squared minus 1. And then I got ready to write it. You remember I was writing it, and I said, oh, the heck with this. By making it pretty and putting a radical in it, all you would have to do if you were, that would make you have to put it back before you did anything with it. So I changed my mind, that's why.
Okay.
I was going to write it like Dr.